Hello everyone. Guys, I will revise with you now some questions on the kinetic molecular theory, phase change, and phase diagram. Hope you enjoy learning kinetic molecular theory in this video. We are practicing some of past exam paper questions here. Question 1. Which of the following is not an assumption of the kinetic molecular theory? You know the assumptions of kinetic molecular theory, that that particles of matter are in continuous motion, they move in very high speed, the collision between particles is an elastic collision, particles occupy a big space while themselves they are very small in size, and so on. So what are what's here from this assumption is not an assumption of kinetic molecular theory. Assumption 1, collision between particles are not elastic. Okay, is this correct? No. Kinetic molecular theory says that collision between particles should be an elastic collision. While gas particles are in continuous motion, that's correct. There are no forces of attraction between gas particles. This is also an assumption. Gases consist of tiny particles that are far apart relative to their sizes. The temperature of the gas depends on the average kinetic energy of particles. So your answer will be only choice A. Question 2. During the process of what? The liquid change to gas. Liquid change to gas only during liquid changing to gas. So what is this process? It's evaporation or vaporization. Question 3. Diffusion occurs faster in gases than in liquids because, first let's explain what is diffusion. Diffusion, like if you have particles of smoke, for example, in air. Air particles, like gas particles in air, are colliding all the time. And on their collision, they move the smoke particles from one place to another. Through the movement of smoke from like position A to position B, when it's get hit by gas particles, we call this diffusion. Diffusion happens as a result of random motion of particles. Diffusion occurs in gases faster than in liquids. And this is because kinetic energy of gases are much higher than in liquids. Or gas particles are far apart from each other than in case of liquid phase. So which choice could be correct here? Liquids are highly compressible? No. Liquids are formed at low temperature? Doesn't make sense. Gas particles are far apart from each other? This answer could be correct. Gas particles are denser, no relation with density. Liquid particles are far from each other, which is not even correct. So our choice will be only C. Question 4. According to kinetic molecular theory, which of the following is true about solid particles? Solid particles, if we compare the solid with gas, we'll say that solids have regular arrangement, particles are closely packed, they have regular arrangement, they have definite shape and volume, and they don't move but just vibrate around their fixed position. This means that all those assumptions are correct. According to kinetic molecular theory, particles of a gas have no definite. Particles of gas, they don't have definite shape or definite volume. We have here volume, so this will be our choice. This question is very simple. You are asked here to compare between physical properties of gas and liquids. The point of comparison is density, compressibility, and fluidity. So you can have this question here, you're asked for compressibility, and instead of is it fluid or not, fluidity. Compressibility means the ability to be compressed, and the fluidity means it can flow. Gases have low density comparing to liquids, so gas have low density while liquid has higher density. Compressibility, gases can be compressed, and this is because they are very far apart, mean there are very wide spaces between particles to compress. Liquids are close, so that we cannot compress liquids. Fluidity, both of gas and liquids are fluids. This question is asking about if you have a balloon and you put it inside a freezer for 2 hours and the balloon was filled with helium. How will the balloon look like after being in the freezer? When you put balloon of helium in the freezer for 2 hours, the particles of gas are going to get compressed because they will lose much of their kinetic energy and come closer to each other. So we expect that we'll have a picture like this one. Answer the following question. Use the kinetic molecular theory to explain each of the following. First, gases are easier to compress than liquids and solids. Gases and particles of gas are very far apart. So if you apply a pressure on a gas, we expect that it can be compressed. So I can compress the gas to let it occupy a smaller volume. So if your pressure is applied, like here, the particles can be compressed in a narrow volume. So this happens in gas. If I compare this with the case of liquid and solid, you will recognize that gas particles are farther apart than in case of solid and liquid states, and that's why there is more space for the particles to be compressed. Question B, both gases and liquids are fluids. Why we describe both gases and liquids as fluids? Fluids mean they can flow. Like when the water can flow from container, honey can flow from its container, smoke particles can flow. Why gases and liquids can flow? Because the particles in gas and liquids are held together by few or weak attraction forces. This means that easy for them to slide past each other or to flow through each other. But in case of solids, particles are very tightly packed, very high attraction forces between the particles, this preventing them from flow. This question is a matching question. You are asked here to match the type of bond with the corresponding description. Covalent network solids means the big molecule, covalent molecules like graphite, diamond. What is the best description for them? You know, in the covalent network solids, particles or atoms are held by very strong forces, very strong covalent bond, intramolecular forces, very strong intramolecular forces. They are arranged in a regular pattern. They have very high melting and boiling points, and they are solids at room temperature. So what is the best description for the covalent network solid? Is extremely hard material and non-conductive. Only graphite, I can say here except graphite. Only graphite is a good conductor for electricity. Molecular solid means small covalent molecule like carbon dioxide, like water. They are just very simple molecules. They can be in any state, solid, liquid, or gas. They don't conduct electricity, and okay. But he is asking here about molecular solids, so we will not say solid liquid gas, they are solids already. So can be melted and reformed at low temperature because they have low melting point and low boiling point. We can give an example of a molecular solid like fat or sugar. It can melt easily at very low temperature. Ionic solid means the ionic compounds. Ionic compounds are made of positive ions and the negative ions that are tightly attracted to each other with strong forces, electrostatic forces. So what is the best description here? Conduct electricity when molten. Metallic solid, here we are talking about the metals. Metals are exhibiting very strong electrostatic forces, attraction forces between the positive metal ions and the sea of electrons around them. They are very good conductor for electricity in any state, in solid and liquid, or even in gas form. So what is the best description for the metallic solid here? Also, metals are malleable and ductile, can be drawn into long, thin wires. I will explain to you here the previous example. The covalent network solid in comparison to covalent molecule that we call them molecular solids, and the ionic solid and the metallic solid. Network solid, this like graphite and diamond and fluorine. Covalent molecular solid like sulfur, like fat or butter, like sugar. Ionic solid like any ionic compound, like for example sodium chloride. While metallic solid like any metal, for example sodium or iron. How can I distinguish between them? Let's explain first kind of forces between the particles. Is it intermolecular or intramolecular? In the network solids, it's just a covalent bond between atoms, but there are so many atoms joined all together with so many covalent bonds. So it's going to make a giant structure. We call it network solids. Like in case of diamond or graphite, this is the structure of diamond. Each carbon atom joined to other 4 carbon atoms. In turn, each carbon atom will join to other 4 carbon atom. Make sure that any atom you draw has 4 bonds coming from it, because each atom is covalently bonded to other 4 carbon atoms. Okay, this is the structure of diamond. In case of covalent molecular solid, like for example sugar or any other molecule, it's just a very simple molecule. It is very simple molecule. In ionic solid, it's a lattice of positive and negative ions, because ionic bond is formed between positive and negative ions. When the metal atom loses its electron, forming a positive ion, like this one, it's a positive metal ion, and this one is negative metal ion, and they are strongly attracted by electrostatic attraction force. Metallic solid, here you need to explain the metallic bond formation. Metallic bond is formed when each atom of the metal loses its electron, its valence electron, so the electron will be between and around the positive metal ions. So it seems that you have C of delocalized electrons. It seems to have C of delocalized electrons around the positive metal ions. And this is going to let the metal ions to held in position by very strong attraction forces. So finally, you will have a structure like this one. The positive metal ions surrounded with C of delocalized electron. Let's go to see now the effect of the structure on the properties of those molecules or those structures. First, the network solid, except for graphite, they are very hard. They have very high melting and boiling point. Why they are hard? Why the melting and boiling point is hard? This is because the forces, the covalent bonds that are formed between the atoms, holding all the atoms in position with very strong forces. In order to overcome these forces, great amount of energy is required, and this is going to help raise the melting point and the boiling point of the network solids. Remember that these forces are intramolecular forces. Intramolecular forces, which is exhibited in the form of covalent bond. In covalent molecular structure, the structure itself is very small molecular mass. If the molecule is small, means the melting and boiling point will be low. Most of them are non-conductor for electricity. Why the melting and boiling point is low? This is because the forces of attraction between molecules are weak. Here, most of those molecules, you can show in them only London dispersion forces, because they are mostly nonpolar. They don't have polar bonds, so the most common forces in covalent molecular solid is only London dispersion forces. London dispersion forces are very weak, so small amount of energy is enough to break and overcome them. This makes the melting and the boiling point of those solids very low. Also, they are non-conductor because they don't have electrons or charged ions to carry the charge. Electroconductivity require electrons or positive and negative ions. We don't have all of them in the covalent molecular solids. Ionic solids, they are made of positive and negative ions that are attracted by strong electrostatic attraction force between the positive metal ion and the negative non-metal ion. Negative non-metal ion. What about the properties? They have very high melting and boiling point. Why? Because the forces are strong. Here, what kind of forces are here? It's also intramolecular forces. Intramolecular forces, because it's just between ions or within the structure, not outside or not between. Regarding electric conductivity, they have ions but ions are tightly held in position. So when they are solids, they are poor conductor of electricity. But in solution, they will conduct electricity because in solutions, ions will separate. The positive and negative ions will separate and they will be surrounded with water molecules. The ions will separate and surround with water molecules. Now ions are free to move in an electric field. They are very good conductor for electricity in aqueous form or in solution form. And even when they are molten, molten means you just raise the temperature until they start to melt. In the molten form, ions are also separated so they can carry the electric charge. Going to the metallic solids ions here are held in position by strong electrostatic forces between what? Between the negative electrons and the positive ions around them. And you can see in your when you write, there are very strong forces between the negative electrons and the positive metal ions. And the positive metal ions are like swimming in a sea of delocalized electrons. Delocalized electron because each atom lost its electrons and now electrons are moving more free around and in between the metallic structure. How this will affect the properties of metals. Metals are solids except for mercury. They are hard except also elements of group 1 that have just very few electrons. They are very good conductors for heat and electricity. They conduct heat because of the vibration of particles. But when you apply heat, if heat is applied from any one side of the metal, suppose you apply heat from here, the positive metal ions and electrons start to vibrate, start to collide one another, transferring the energy from one molecule to another. This is how heat can be transferred. For electroconductivity, the electrons can move freely within the metallic structure, and that's why they are very good conductors of electricity. Let's read this question. Some properties of liquids are listed below. Answer questions A to C. Why does water form a meniscus or curved surface in a test tube? Justify your answer. Why the water in a test tube make a meniscus? If you have a test tube or beaker and you put water in it, you will see that water will make a meniscus, will make a curvature like this. This means that there is a pulling force from the container, the sides of the container, and liquid particles or water particles. The force of attraction between water and the wall of the container is called adhesive forces. So we have here adhesive forces between water and the test tube wall. There are other forces between water molecules, which is a resultant of the hydrogen bonding between them. These forces are called cohesive forces. So there are cohesive forces between water molecules one another and the adhesive forces between water molecules and the wall. Because of those forces, meniscus may appear. Here, if the adhesive forces is higher than or stronger than the cohesive forces, is going to make a curvature downward like this. Question B. Explain why honey is more viscous than water. Why honey is more viscous than water? This means that the forces of attraction, the intermolecular forces, are stronger in honey than in water. This is very simple. Okay, honey has stronger intermolecular forces than water. These forces prevent the honey molecules from flowing easily. This is a simple application for what we have just said about fluidity. Because both gases and liquids are fluids, honey is also a fluid. But the fluidity depends on the forces. The weaker the forces, the more the substance will be fluidy. So water has weaker forces than in honey. That's why water is more fluidy than honey, or honey is more viscous than water, because viscosity is an opposite to fluidity. Question C. Why does water have higher surface tension than other liquid? Justify your answer. Why water has higher surface tension? What is surface tension? Yes, surface tension is when the water surface becomes like a sliding surface for insects, for people, for wood. And also, if you see the drops of water on the leaves in the early morning, you can see them. Drops of water on the leaves in the early morning, all of those features are attributed to surface tension. Why water have high surface tension? This is because the water molecules at the surface form a hydrogen bond with other water molecules beneath them and beside them. Suppose you have a water molecule in the middle. The water molecule in the middle is going to attract other water molecules around it with the hydrogen bonding, as we have thus discussed. So, as a result of that, the surface water molecules are drawn inward or downward, creating less surface area means more surface tension. I will repeat again. The water molecules attract water molecule in the center, attract other water molecules around it, forming a spherical structure. This spherical structure help to reduce the surface area of the liquid. Reducing surface area means increase surface tension. Which of the following assumption is valid based on the kinetic molecular theory? Gas molecules have negligible volume. This is correct because we said that the gas molecules are very small comparing to the space they occupy. 2. Gas molecules exert no attractive forces on one another. This is true. We said there are no attraction forces between gas particles. 3. Temperature of a gas is directly proportional to its average kinetic energy. This is also true. When the kinetic energy of the gas particles increase, the temperature will increase. So all of them are true. The average kinetic energy of particles in a substance is measured by how to measure the average kinetic energy. Average kinetic energy is measured by the temperature. This is the definition of temperature. Average kinetic energy of the particles. According to kinetic molecular theory, particles in the liquid are bound in fixed position. No, this is applicable for solids. Highly ordered arrangement. This is also only applicable for solids. Move around randomly and constantly. This one can work. Vibrating fixed position. Also, this is only for solid. So the answer will be C. Let's see this question about the phase diagram. The point represents the triple point as. Let's label the whole diagram, all the letters. C, the region CB, here is the equilibrium between the solid and the gas phase. And the line BD is the equilibrium line between liquid and the gas phase. And this line is representing the equilibrium between solid and liquid phase. The point here, so any point on this line is called melting point. So we call this point melting point, or the whole line melting point line. The line which between solid and gas here is the sublimation line or deposition line, because here is the point at which solid changed to gas or gas changed to solid. Here is the change from liquid to gas, means it's a boiling point or condensing point. So this line represents the boiling point. You can see also in the graph this point that we said that we call it critical point. At both sides of the critical point, matter in its required state. So the matter here is gas and here is liquid. But just behind the critical point, you cannot distinguish the liquid from the gas. Critical point. So the fluid in this area is described as supercritical fluid. Now we can answer the question, what is the point which represents the triple point? Triple point is where the three phases coexist. Here is the liquid, and here solid, and this is gas. So at this point, which we call triple point, the three phases coexist. So the point which represents the triple point here is point B. Question is asking about the critical point. The critical point is point D, as clear from this graph. So the critical point is point D. Use kinetic molecular theory to explain why liquids are fluids. According to kinetic molecular theory, particles in liquid can change relative positions, but is still influenced by attractive forces. Thus, they are able to move freely. Particles in liquids, as you know, they are arranged in a way that they can slide past each other. There are forces between them, but the forces are not strong enough. So because of the two opposite features, that the particles can change their position or can slide, you can say here, can slide past each other, and they are still attracted by attraction forces between the particles, so they can move freely or they can flow. Inshallah, we'll complete solving the rest of the problems and questions in the following videos. Thank you.